everybody, welcome to Chapter 3. You're going to want to join me with your Chapter 3 notes. We are going to be solving and graphing inequalities in this chapter and compound inequalities. Here are our goals for Lesson 3.1. We want to be able to write an inequality from a verbal phrase and from a situation, and we want to be able to graph inequalities. Now these are things that you've done before, so we're going to be reviewing. Here's our inequality symbols. There's a section in your notes for you to jot these down. Think about the word inequality. It has the prefix in, and in means not. So inequality means not equal. Just like the word incomplete means not complete. So we've got less than, greater than. These ones have the equal to symbol underneath it. So this says less than or greater to, less than or equal to, and this one says greater than or equal to, and of course this is just not equal with the slash through the equal sign. Now a lot of times kids will try and remember the less than symbol as less than left hand. So if you use your left hand, it makes a less than sign. Also, the less than kind of looks like an L. You've got to be able to tell the difference between these symbols and not just the bigger mouth eats the bigger number like elementary school. You need to see this sign in isolation and know that it means less than. Same thing with this one, and know that it means greater than. Okay, so if you need to pause the video to write them down, go ahead. You may not realize it, but most real life situations involve inequalities. Most of the time, situations in real life can be better written with an inequality statement than an equation. So here are some examples of situations. Signs that you would see. Getting 20 bucks to go to the mall or to the movies. You don't have to spend all of it. An inequality can be written to represent that situation. Same thing with this sign. Or this, voting age, pool capacity, speed limits. All of these situations represent an inequality statement, or an inequality statement could be written to represent that situation. So let's begin. Let's talk about prior knowledge. If I gave you the equation x equals 4 and I asked you to graph it on a number line, how would you graph that or plot it? Yeah, you just shade in a dot at 4. There you go, x equals 4. Now how would you graph x does not equal 4? So we don't want to include 4. Well, instead of shading in the 4, you would leave an open circle at 4, but everything else would be shaded. Because if x doesn't equal 4, it would equal everything else. So we wouldn't want to shade that. Now the idea of the closed shaded in circle to include 4 and the open circle to not include 4 will be used when we're graphing inequalities. You might recognize this whole idea of the open and closed circle. So let's talk about graphing inequalities. So here I have x is less than 3. That x represents all numbers. All numbers less than 3. I want to graph that. Well, I want to find the 3 on the number line here. Do I want to include 3? No, I want everything less than 3. So I don't want to include 3. That means I don't want to shade 3. So I'm going to have an open circle at 3, but everything to the left gets shaded. These are all numbers that are less than 3. How about x is less than or equal to 3? So this would include all numbers that are less than 3, but also equal to 3. Would we want to include the 3? Yes. So we're going to want to shade in the 3 with a closed circle, and everything less than it would also get shaded. Now notice something about these two. The symbols are less than. Don't they look like the head of an arrow? It almost looks like this is an arrowhead pointing the direction that we shade. And that's the case as long as the x or the variable comes first. You can use that trick. Let's try this one. Y, which is the variable representing all numbers that are greater than -5. Okay, do we want to include -5? No, we want everything greater than -5. So I'm going to find -5. I don't want to include it, so I'm going to put an open circle. All numbers that are greater than -5 go this direction. So I want to shade all of those solutions. Here, all numbers that are greater than or equal to -5. So because I say equal to -5, I want to include it. So I'm going to find my -5 and I'm going to make a closed circle at -5 to include it because it says it could be equal to -5. Or everything greater than going to the right. Now let's test that idea of the arrowhead. Do you see the greater than symbol? Looks like an arrowhead pointing this way. And you notice that that's the direction that we shade. That is always true as long as the variable or the letter comes first. Okay? So anytime we see greater than or less than, we want to use an open circle. Anytime we see greater than or equal to or less than or equal to, we want to close it because we're including the number. So we want to shade it. Let's do some examples of working with inequality. So here's example number 1. Let's write the inequality that represents the verbal expression. Remember, that was one of our goals. So here we have all real numbers x that are less than or equal to 5. I want you just to circle the words in this statement that represent the inequality symbol. Is that what you circled? Less than or equal to. That's our inequality symbol. So I'm going to start off with an x. Our less than or equal to, I want to make that symbol. So less than, left hand. Less than or equal to 5. I'm simply taking the words and I'm just changing them into an expression with an inequality symbol. Let's try the next one. 4 less than a number y is greater than 10. Circle the words that represent the inequality symbol. Did you circle these words? Good. So we have 4 less than a number y. We learned how to write that expression in the very beginning of the year in chapter 1. 4 less than y. I have y and I want 4 less than it. So minus 4 after it. That was a turnaround word. And then is greater than 10. So I just simply took the words and I changed them into an inequality statement. That was example 1. Let's try example 2. We're going to test to see if each of these numbers is a solution to this inequality statement. It says 3 times x minus 2 is less than negative 1. Now think about if this was an equation, if I change this to an equal to sign, and I asked you, is 4 a solution? What would you do? Well, you plug it in, right? You plug this right in here for x to see if it's true. Same thing with an inequality. If I'm asking you if 4 is a solution, you take that inequality and we're going to plug 4 right in here for x. And we're going to ask ourselves, is this true? Well, let's simplify a little bit. 3 times 4 is 12. Bring everything down. 12 minus 2 is 10. Now I have a statement here. 10 is less than negative 1. Now when you start to compare, you can think about that big mouth eats the bigger number, right? This is saying 10 is less than negative 1. Not true. Do you see how the big mouth is opening to negative 1? That's not bigger. So the answer to this would be no. 4 is not a solution. Well, let's test negative 3. So I'm going to start with the inequality, and I'm going to plug in negative 3 right here for x. And I'm going to check to see if it's true. So let's simplify. Multiply here. We get negative 9. Now I'm going to simplify here. Negative 9 minus 2, negative 11. Now I got this statement. Is it true? Is negative 11 less than negative 1? The big mouth is opening to the negative 1, saying that that's bigger. That's true. So yes, this would be a solution. So I'm testing solutions for inequalities just like I can test a solution for an equation. Let's try number 3. This one's kind of tricky. It says, what is the graph of 4 is greater than or equal to b? I'd like you to pause the video and with your pencil, go ahead and try and graph that. So now you checked it, right? Or you graphed it? Okay, let's check and see here. 4 is greater than or equal to b. Now, most of the time, it's very helpful if you use the head of an arrow trick. But can you use that trick right now, the way that this inequality is written? No. You'd have to reverse it. You need to get the variable on the left. Anytime we're working with inequalities, always just make it a point to get the letter first on the left. So if I reverse it, it says 4 is greater than or equal to b, I'm going to flip that around. Now think about this. If I have 3 is less than 5, I can reverse these two. 5 is greater than 3. Do you see how that big mouth is opening to the 5 because it's bigger? This is equivalent. The big mouth is still opening to the 5. Okay? So I'm just going to take these and I'm just going to spin them around. I'm going to make the b right here and the 4 right here. The big mouth is opening to the 4, so I'm going to make the big mouth opening to the 4. These two are now equivalent. It says 4 is greater than or equal to b, then b is less than or equal to 4. Okay? As long as that big mouth is still opening to the same bigger number, I just can take it and flip it. Okay? So now that I've changed it and I've rewritten it, now I can graph it. So I need what kind of circle at 4? Open or closed? Yep, closed. It says all numbers less than or equal to 4, so we want to fill in color in 4, and everything less than it goes this way. Were you correct when you first shaded it? Hopefully. All right, let's try 4. What inequality is represented by the graph? I like these ones. I think they're fun. Now again, whenever you're writing an inequality, the variable always comes first. Let's use an x. So x is, I'm going to fill in the inequality symbol, and then this is the number I'm comparing it to. Okay, so I have all numbers that are what compared to the number I have shaded? Well, I'm comparing it to -2. This is what I have shaded, -2, so I'm going to put that right here, and here's my inequality symbol. Do you see how everything to the left is shaded? So my inequality symbol has to point that direction, and being that I have a filled in circle, I need an or equal to. So this says all numbers less than or equal to -2. And I can see that that's my graph. Pause the video and try this one. All right, let's see if you're right. I look at the number that has the circle, put it right here. Then I take a look at which direction is shading. Shaded this way, to the right. So my inequality symbol has to point the direction that I shade. It's open. Do I need an or equal to? No way. Let's read it. All numbers greater than 1. Yep, that's all numbers greater than 1. These are kind of fun. Always start with the variable. X is a good one. And then you're just looking at which direction do you shade. Is it open or closed? And you're putting your number right here. What are you comparing it to? All right, let's go to the next one. We want to be able to write an inequality from a situation now. Here's the situation. Sometimes when you're at an amusement park, you'll see signs like this. So we have a height requirement. You have to be over 48 inches to ride on this ride. Okay, so let's write an inequality representing all of the people that could ride on the ride. How tall do they have to be? So we're going to start off with an X. We want an inequality symbol, and then 48 is the number we're comparing it to. So the riders must be what compared to 48 inches? Could you be 48 inches? No, it says over 48 inches. So you have to be greater than 48 inches. All numbers or all heights greater than 48 inches. Think about if you were to graph this. Sometimes it makes sense if you think about graphing it. So think about the number 48. If I put 48 on a graph, I would have an open circle because I wouldn't be able to ride the ride if I'm 48 inches. But all the other heights that are taller than that would be able to ride the ride. So this might be able to help you determine which direction your inequality symbol goes. Let's try this one. Speed limit, 25 miles an hour. So if the legal speed limit's 25 and you're not going to go over that, what are the speeds on the road that the drivers could go? Okay, so let's write an inequality. The speeds that they could go would be what compared to put the number 25? Okay, so again, if it helps you to sketch a little graph, I think it's really helpful. So if I put the number 25 here, could I drive 25 miles an hour on this road and still be legal? Yeah, so I would shade that in. Now, could I go faster than that? No, I could only go up to this. So my speeds would then have to be less than this, wouldn't it? Yeah. So the speeds that I could drive would have to be less than or equal to 25 miles an hour. So again, the little sketch just helps me to see that my inequality arrow points that way. The speeds would be less than or equal to 25. That's the max. Okay? You don't have to have these little sketches. I just think that they're kind of helpful to determine which direction to put your inequality symbol. So I think that we've done everything here, haven't we? All of our goals, I think we've met them. So let's do a little summary. I think this will be important to put in your notes, or at least follow along with me. What is important to remember when graphing inequalities? Think about what's important, what's kind of like the highlight here. When I'm graphing an inequality, what do I need to think about? Well, first of all, the variable needs to be on the left. You have to start with the variable. So if you're given an inequality like this, don't even start to graph it. You need to take that inequality and rewrite it. So do you see what I did? I just took these and I flipped it. Do you see how the big mouth is opening to the x? and the big mouth is still opening to the x here. So no more of that. Take that away, reverse it, okay? These are saying the same thing. If 4 is less than x, then x is greater than 4. They're equivalent. It's just I gotta have the x first, and then I can go open circle and shade the direction of the arrow, okay? So you always want the variable on the left. The second thing would be that the inequality arrow points the direction you shade. So if the arrow points this way, I shade this way, as long as the variable's on the left, okay? So then you can use that little trick. Third thing, you need to pay attention to, do I open the circle or do I shade and close it in? So open circle with less than or greater than. A closed shaded in circle with the or equal to, because then we want to include that number. So if you want to, pause the video and then write down these 3 key things to be thinking about when you're graphing inequalities. Thank you for joining me for lesson 3.1. Have a great day.